Good morning, dear student. In today's lecture, we are very much interested in the enzyme substrate complex formation. So, before discussing how this enzyme substrate complex is formed, let's discuss some important points regarding to this enzyme substrate complex formation. The first one, that is your active site. So, what is active site? The portion of the enzyme which is responsible for the catalytic activity, the portion of the enzyme which is responsible for the catalytic activity, and hence for the conversion of reactant into the product. Conversion of reactant into the product is known as the active site of the enzyme. So if we see the reaction, that is the enzyme plus substrate, it will forms enzyme substrate complex. So this is your this E, it is your enzymes, and this is S stands for your substrate, and they will forms the complex, that is enzyme substrate complex, and the equilibrium is developed. The reaction is reversible. Okay, and this is very fast step. That is the formation of enzyme substrate, and the enzyme substrate then further it is converted into the product with free enzyme, with formation of free enzyme. So with formation of product, along with product, so we get free enzyme. So this is the reaction, that is when the active site of an enzyme E binds with substrate S. Okay, so S stands for the substrate and E stands for enzyme. When the active site of an enzyme E binds with substrate S, it will forms enzyme substrate complex, and this enzyme substrate complex is then converted into the product. It is then converted into the product, and it is very important to note that. So it is very important to note that the enzyme only increases the rate of the reaction. Okay, so the main important point, what is the role of this enzyme in this enzyme substrate complex formation reaction? Okay, or the conversion of substrate into the product, it increases the rate of reactions. Here I will write first point, that is it increases the rate of reaction only. It increases the rate of the reaction only, but it does not alter the reaction equilibrium. Okay, so it does not alter the reaction equilibrium, it increases only the rate of the reaction. So there is no effect on the equilibrium. Okay, the equilibrium not disturbed by these enzymes. So it this enzyme, it increases the rate of the reaction by lowering the activation energy, by lowering the activation energy. So if you see this diagram, the energy curve is given, that is along y-axis, that is the free energy change, that is delta G, and along x-axis there is a reaction coordinate. And if you see this graph, okay, the substrate is converted into the product. Okay, and in absence of catalyst, that is in absence of enzyme, and in presence of enzyme, if you see the difference of delta G, which is necessary to convert the substrate into the product. So minimum energy which is required to convert the substrate molecule into the product, it is nothing but your activation energy. So in presence of enzyme, the activation energy get lower as compared to the uncatalyzed reaction. So if you see the difference here, so this is the delta G in presence of enzymes. So lower the activation energy means higher will be the rate of the reaction. So this enzyme, it increases the rate of the reaction by lowering the activation energy. Okay, and if you see this point, that is your transition state is given. This delta G, it is in presence of it is in absence of catalyst. It is in absence of catalyst means it is in absence of enzymes, that is uncatalyzed reaction. So it should have a high activation energy, and its rate of the reaction is very slow, that is it will take longer time to convert the substrate molecules into the product. Okay, so this is very important. So what is this active site? So at least you should know what is active site. That is the portion of enzyme which is responsible for catalytic activity, it is known as active site. And the reaction, that is enzyme plus substrate, the equilibrium is developed, and then the formation of enzyme substrate. Enzyme substrate, again it is converted into free enzyme with formation of product. And if we see some important points regarding to this enzyme, that it increases the rate of the reaction by lowering the activation energy. So this is shown in this diagram, that is the graphical representation between the energy change versus reaction coordinate, and the substrate molecule is converted into the product in presence of enzyme. In absence of enzyme, the difference is shown in the figure. Again, this enzyme only increases the rate of the reaction by lowering the activation energy, but it does not alter the reaction equilibrium. It does not alter the reaction equilibrium. Okay, so this is all about the enzyme substrate complex formation reaction. In the next lecture, we will discuss the enzyme specificity.